In this demo, we'll be taking a look at how AccuKnox can help you improve the security of your LLM deployments on Nutanix GPT-in-a-Box setup. The infrastructure of GPT-in-a-Box consists of three main components: a Linux-based jump host, an NKP or a Nutanix Kubernetes platform cluster, and a Nutanix file server. The jump host is responsible for generating LLM archives and managing the deployment of inference service. The inference service is run in the Kubernetes cluster and is exposed through an API. And the Nutanix file server is a network file server shared between the two of them. So a demo is going to be applicable for both hosted and on-prem deployments of GPT-in-a-Box. So let's start by taking a look at how we can secure the jump host. This is the jump host. It is a Linux virtual machine, and as we can see, it has an NFS mounted at /mnt/llm, and this directory contains the language models, and within those directories it's the model archive and any configuration that is needed by the inference engine to deploy the models. So since this is a read-write path, I would be able to write anything to it without any problems, which is not desirable, as if the jump host is somehow compromised, then malicious actors might be able to tamper with existing models or deploy models of their own, which is not good. Another risk in the jump host is the presence of a kubeconfig. So basically, the GPT-in-a-Box scripts require access to the Kubernetes cluster so that they can deploy the Kubernetes inference service, and because of that, a kubeconfig has to be present on the jump host. You can set RBAC on it, but it will at least need access to deploy and make changes to the LLM deploy service. So we need to classify this as a sensitive asset, because if an attacker gains access to the jump host, they can use the kubeconfig to cause harm to your Kubernetes cluster, to your deployments, and so on. Let's see how we can secure against these two risks. I have the node already onboarded onto AccuKnox, and what I'm going to do now is apply a couple of policies on it. So this is the policy that I've created already, and what it is going to do is allow only Python programs to write to mount LLM directory. This is Python program for this demo. You can set it to anything else based on how granular you want it to be. And similarly, we will be blocking any write access to mount/LLM. The read access will still be allowed, so that syncing and other purposes between the NFS and the host can still work. But this will make sure that we have limited access to the mount LLM directory. Similarly, we have this another policy which is going to audit any access to the kubeconfigs present in the cluster. So this audit alert will be sent to AccuKnox, and administrators can accordingly take an action. So I'm going to activate these policies, and now let's see them in action. So if I try to tamper with any of the model's configuration now, I won't be able to do so, and I'll be denied the permission when I try to write. This is happening as KubeArmor, the runtime security engine that powers AccuKnox. It uses something called inline mitigation, comes into action, and before anything can happen, it denies it and sends an alert to AccuKnox. So if I see the alert that was generated for this, we'll see that a process tried to write to it, and I got an alert here saying that it was denied. I can get all the information about it here. Similarly, if I try to access the kubeconfig through kubectl now, this action will be audited as well, and I'll get an audit alert here, which will say that a sensitive asset was accessed by kubectl and the other information that's useful. So using these two policies itself, you can reduce the attack surface of the jump host by a lot. And similarly, more policies can be created which can help you secure the jump host. Now let's take a look at the Kubernetes cluster, the NKP that is running our inference engine, and see the risks associated with it. So basically, depending on the deployment model, the inference engine might be running a trusted or an untrusted model. So if the model is untrusted, there is a certain possibility that it might have some vulnerabilities which an attacker might be able to use to break out of the designated container that this pod has, and access some of the other deployments on the pod, access the Kubernetes cluster itself, and compromise the entire system. So what we want to do is to prevent this, and we want to make sure that the inference engines run in a sandboxed manner. Other than this, another possibility is the shared NFS that is present here is configured as a read-write persistent volume claim. So if any cluster misconfiguration slides in, then it is possible that this inference engine also has the access to write to this NFS, again causing poisoning. So let's take a look at the deployments first. So there's a deployment named LLM deploy, which is running our inference service, and it has some pods running as well. To test this out, I have created this script, which basically creates an API call to the inference service API and sends a prompt, gets back a result. So to check if everything is working fine, let's first execute the API call. And we'll see that we sent this prompt and we got a result back, and it also came with some metadata like what model was being used and so on. So another thing we could check is the deployment itself. If we take a look, then the KSAR PVC resource, which is a persistent volume claim, is not present as read-only, and this is at the pod level, the volume at the pod level. If we misconfigure one of the containers, the container might have read-write access to this PVC resource. So let's take a look at how we are going to achieve sandboxing first. I have my cluster already onboarded onto AccuKnox, and within this cluster I can see all my workloads. I'll focus on the LLM deployment, which is running my inference service. And first I'll take a look at the application behavior, or what all is happening inside my container. So if I take a look here, I'll be able to see what all files are being accessed, what all processes are being executed and how often, and what all network activities are going on. So what AccuKnox does is, based on this, the profiling data, it creates policies that define a least permissive posture for your deployments. So I have this discovered policy, and what it is going to do is allow only certain processes to execute, only certain processes to execute to access these network protocols, and only certain file accesses to happen. So let's apply this policy. And other than kubearmor policies, AccuKnox also discovers Kubernetes network policies based on your CNI supports it or not. So we can use these as well to achieve network segmentation. For now, let's take a look at the kubearmor policy. And while applying the policy, there was no effect on the uptime. I'll check if my service is still running fine, and when I send a prompt, I get back a result. So this is working fine as well. Now, to simulate a vulnerability and an attack scenario, if there is a vulnerability, an attacker might be able to gain access through the inference service, through the model in the inference service, and gain a shell onto the deployment. So I'm going to try that. And I'll see when I do so, I am denied the permission to do so. And this permission denied has happened in real time. There has been no impact on the uptime of my application. It is running as usual, and I'll still be able to access the API and do pretty much anything. So this way we have sandbox our application. If we see onto AccuKnox SaaS, I'll get an alert for this, which says that something tried to gain access to a shell inside the deployment, and it was denied the access to do so. So we can take these alerts and then we can send them to any of these integrations and have a much more impactful messaging.